101 project and our group, the Diodes, have chosen the topic of application of diode. So we are going to explain
Why so serious?
We are going to explain briefly about the laser diodes. In this video, we're going to give you an animated representation of a few concepts that's used inside the laser diodes. Finally, we are going to show you the assembling of the driver circuit by using a little learning model. Thank you. Enjoy the video.
Let us talk about Pyeong junction diodes. It comprises of two semiconductors, one the p-type containing an excess number of holes and a few electrons, and the other n-type with excess number of electrons and a few holes.
When a voltage is applied across the p-n junction, the electrons get excited. This is a ground state electron. When energy is applied to it, it gets excited and jumps up to the higher energy level. It then loses some energy and comes to a lower energy level. It again loses a huge amount of energy and comes back to the ground state.
When we supply energy to the p-n junction diode, the electron and the hole combine to release a photon. This stimulates the other electrons and holes to combine and release photons as well.
The p-n junction is surrounded by mirrored surfaces to trap the photon of light. The photon bounces around the p-n junction. Now, due to stimulated emission, the p-n junction is filled with laser light, and a vast majority comes out to the hole in a straight line.
This is the driver circuit which controls the current flowing through the laser diode. In the circuit, we have a regulator LM317 which limits the voltage to 1.25 volts. The resistor controls the current using Ohm's law. The diode in parallel protects the laser diode if the batteries are inserted the wrong way, and the capacitor eliminates voltage spikes. We are making the circuit of the laser diode driver. Here we have the breadboard which will act as the base to assemble all the components on the circuit. On the breadboard, in the outer two regions, the holes are connected horizontally, and in the inner two regions, the holes are connected vertically. Now we start with the switch which is connected in series with the LM317 and the positive terminal of the battery. Now we create the resistive component of the circuit. The two 10 ohm resistances are connected in parallel with each other, and the entire combination is connected in series with a 200 ohm variable resistance. This resistive component is then connected across the LM317. Now from one end of the two 10 ohm resistors, we connect the capacitor and the diode in parallel with each other. And the other end of this parallel combination is connected to the negative terminal of the battery. This completes the laser diode driver circuit. Now to connect the laser diode, we connect it in parallel with the diode and the capacitor. And thus our entire circuit is complete.